Hi everyone, in today's video I am going to discuss the third principle of solid design principles, that is Liskov substitution principle. So I have already covered the single responsibility and open closed principles in my previous tutorials. I highly recommend to watch those videos and the link is in the description box. In this video, I'll first discuss what is Liskov substitution principle, then I'll take multiple code examples to explain this principle thoroughly. So please watch this video till end and you will understand this principle in depth. Let's start this video with the Liskov substitution principle, and it states that the objects of a superclass should be replaceable with objects of its subclasses without breaking the application. Right? So here we are not only talking about the semantics but also the behavior. So to understand this, let me take an example. So suppose there is a class A and in which we have created some method do something, right? So I'll take more concrete example when we write a code, but for now let's continue with class A and B, right? So this method, this do something method represents certain behavior, and let's suppose the behavior is it takes the list and removes the first element from that list. And class B extends class A and it overrides the do something method. So the expectation here is it also replicates the same behavior. So what I mean behavior is, that is, it also removes the first element from the list. So whatever logic it want to write to remove the first element, it's up to them, that's fine, but it should not change the behavior. For example, it should not remove the last element from the list, as in this case the behavior is changed and it violates the Liskov substitution principle. So in this case, if we substitute the object of B in place of A, it will totally change the functionality or behavior of the code, right? So the expectation here is it removes the first element from the list, but now if we extended this class A and in do something, if we change the logic, if we change the behavior that it will remove the last element from the list, then if we substitute the object of B in place of A, and when we call this do something method, it will totally change the functionality, right? So it's a clear violation of the Liskov substitution principle. So now again, let me repeat the principle again. If substituting the superclass object, here the superclass is A, with a subclass object and the subclass, here the subclass is B, changes the program behavior in unexpected ways, then the Liskov substitution principle is violated. Before writing a code, let's discuss some important point regarding this principles. So the first point is it's applicable when there is supertype subtype relationship. So either by extending a class or implementing an interface. So either we are extending a base class or we are implementing an interface. So this principle is only applicable when there is supertype and subtype relationship, right? So next point is we need to make sure that new derived classes are extending the base classes without changing their original behavior, which we have discussed. So how changing the behavior violates this principle. Now the third important point is if a subtype of the supertype does something that the client of the supertype does not expect, then this is the violation of Liskov substitution principle. So imagine a derived class throwing an exception that the superclass does not throw, or if a derived class has some unexpected side effects, then this is the clear violation of Liskov substitution principle. So now we have covered enough theory. Let's open the editor and start writing some code. Let's start with our first example, and it's a classic example of Liskov substitution principle, which is related to the rectangle and square. So we all know what rectangle is. So a rectangle is a polygon with four sides, where two parallel sides are equal to each other, and it has width and height, right? So here I have created a rectangle class, and in this class the two attributes are width and height. And also I have created a constructor, right? And it's getter and setter. And we have one more method, calculate area, which calculates its area. So its area is basically width multiply height. So nothing complicated here, right? Let's see another class, which is a square. And this class square is extending a rectangle class. So there exists is a relationship. So basically square is a rectangle. So by definition, square is also a polygon with four sides, and all of them are of equal length. So square is a special type of rectangle, right? So that's what we have done here. So this square class is extending a rectangle class. So square is a rectangle, and all of the sides of a square is equal. So basically all of the sides are of equal length. So it's taking only one parameter, which is side. So in constructor we take only one parameter, which is side, and we are calling the parent class constructor and passing the same value for height and width. And apart from that, we have overridden the setter. So whenever someone calls set width or set height, we set both the height and width, and we pass the same value for both height and width, right? So because we are ensuring that whenever any width or height is set, we pass the same value so that it satisfies the property of a square, and its property is its all sides are equal. So that's about the square class. Let's open main class and run some tests there, right? So in main class, if you see, there exists this verify method which are accepting the reference of a rectangle class, where we have set the height and width, and then we have printed what's our expectation, and then we are printing the output. Basically we are calling this calculate area method, and whatever value is returned we are printing there, right? So here we are calling this method verify for the rectangle and square instance, and then we are printing our expectation and output. So let me run this code, and it's running, and if you see the expectation is 600, which we have written here, and the output is for rectangle it is 600, and that's fine, but for square it's 900. So basically by seeing this statement, we know that there is something wrong. There is something wrong with the inheritance we have done in our code, right? As there is a difference in expectation and actual result. So basically if the area of a rectangle is height multiply width, but we get some different output. And also you have noticed that the setter we have used in square class, basically this one, set width and set height, is actually a very bad kind of setter. So when we call set width or set height method, it set both the height and width. So here we have modified the behavior, which is the violation of a Liskov substitution principle, right? So we know that there exists some problem the way we have inherited the rectangle class and the way we have overridden the set width and set height method. So now let's discuss how we can fix this problem, how we can uh, modify this code so that it can uh, satisfy the Liskov substitution principle, right? To fix this problem, we have to break the relationship. So we have to break the inheritance relationship between the rectangle and square class. As this relationship is not valid and also it violates the contract of set height and width method. Right? So what we can do is let's create an interface shape, and in shape we can define one abstract method which is calculate area. So it is the common behavior for both the classes. So both rectangle and square class implements this interface shape and define the contract of define this calculate area method, right? So if I open the rectangle class, it will implement this shape interface and it defines the body of this calculate area method. Now let's see in square class. So we have declared one attribute which is side, and we have defined its getter and setter. So we have break the relationship. So earlier earlier it was extending the rectangle class, but now it implements this shape interface, and also it defines this calculate area method. And calculate area is basically it's the area of a square is its side square, right? So it defines this method also. So this is the common behavior between these two classes. So let me open the main method, and in main method we have declared the instance of we have created an instance of rectangle and square, both is of shape type, and in verify method we have defined any class which have implemented this shape interface, it is accepted in this verify method, right? And we have called its calculate area method. So first we have declared this rectangle class, and this rectangle in constructor we have passed the value of height and width, and for square we have passed the value of side. And let me run this code, and when we run this code, now you can see the output is 600 and 400, right? By implementing this interface, both the classes ensures the behavior of calculate area, right? Now they are following the Liskov substitution principle. So let's take our second example, and in second example also we first see the case where Liskov substitution principle is violated, and then how we can refactor the code so that it will follow this principle. So let's move to our second example. Our second example is related to media player, as media player plays the audio and video files. So here I have created a class media player, and in this class there is two methods, play audio and play video, right? And then we have one class DVD player, we have another class DVD player which extends this media player and overrides play audio and play video methods. So there is a relationship. So DVD player is a media player, right? And it overrides both these methods. Then we have one more class Winamp player, which is also extending this media player class. But this player can only play audio files. So we have overridden both the methods, and in audio files, it's fine. We have written some business logic, assume there is some complex logic involved here. And in play audio, as it is not supported this play audio feature, so so we have thrown unsupported operation exception, as playing video is not supported in this player, right? And now let's open our test class, in which we we have created the instance of DVD player and Winamp player, and both is of type media player, right? And we have this play method which only accepts the reference of media player class. So any class which is of type media player is accepted here. So here the expectation is whatever class we pass in this method, it can play both audio and video, right? So let's run this code. Let me run this code. And it's running. So now you can see what's wrong here. For DVD player, it's fine, right? We can play both audio and video. But for in case of Winamp player, it is throwing, for playing audio it's fine, for video it is throwing unsupported operation exception. So which is the clear violation of Liskov substitution principle, as we are not able to substitute superclass object with subclass object without changing the behavior. So the behavior is to play video, but it throws unsupported exception. So now you know we are doing something wrong here, and we have to refactor the code so that it supports this principle, right? So let's refactor our code. As we have seen, not all media players support playing both audio and video. So we can segregate both the features in two different classes. So media player play only audio, and then create one more class which is media player, which extends media player and add the capability to play video, right? So video player is a media player which plays both audio and video files. So I hope it's clear. And then we have a class DVD player which plays both audio and video, so it extends video media player. And the Winamp player which can only play audio, so it extends this media player class. And now if I open this test class, and here we are passing the reference of media player class. Any class which is of type media player can be accepted here, and you can see the expectation is change here, right? So it only expect playing audio. And if I run this code, so let me run it. So now both the classes support playing a video. And what if I have to run both audio, I have to play both audio and video? So let me just write this video media player, right? And if I change this video media player, and definitely this Winamp player is a media player, but it's not a video media player. So you can see we can't pass the reference of this Winamp player, right? We can only pass the reference of this DVD player. So reference of any class which is of type video media player, and we can play both audio and video. So let me just write play video here, right? So now you can see the clear difference here. We can substitute superclass object with subclass object without changing the behavior, right? So this is all about the Liskov substitution principle, and I hope you have understood this principle in depth. So please like and share this video with your friend and colleagues. So that's it for this video tutorial. Thank you very much for your time.